Okay, quick screencast to accompany this Azure Quick Start guide for the CAP Alert Hub. Elliot and I have been asked if it's possible to run AlertHub on Azure, and it turns out to be reasonably straightforward. So we've created this document which explains how to do it, and this screencast is just going to walk you through the process just to prove it can be done, really, I guess. I've got my Azure desktop here, and I'm going to click on virtual machines. I'm going to add a new virtual machine in my test resource group. I'm going to call the virtual machine AlertHub. It's going to be UK South, Ubuntu Server 1804, that's an important bit. Now, size. A standard D2S machine with 2 virtual CPUs and 8 gig of memory is entirely sufficient to run an AlertHub in its normal operation state. The only wrinkle is that when we first install an AlertHub, there are over 200 feeds we need to synchronize with, and the loading on the system just at startup is quite high, and the process becomes CPU bound. Because I want to do a demo that's not, that doesn't keep us all waiting, I'm going to up this to a 4 CPU system. 2 is entirely sufficient for normal operation on a test system, but also the setup I'm running here is again a test system. You probably wouldn't configure a production system like this. You would want to separate out the components and run them on different servers. So this is very much a proof of concept. And if you want to do this in production, you probably need to talk to Elliot and I about the best way to organise things. So let's go instead for this D4S v3. We'll select that. In order to set up a server, we need a public key, an SSH key. So I'm going to call my username AlertHub, and I need a key. There we go. So that's my public key. And the only other thing we need to do on this screen is to enable HTTP access. We could configure the server to do HTTPS, but if you really want HTTPS, you're probably going to do that using Azure's HTTPS termination and services, pardon me, rather than doing it in the box itself. That's everything we need on this screen. We do need some storage, so we're going to go next disks, and premium SSD is fine. Create and attach a new disk. The name's fine, but we only need 256 gig for this test. Sorry, the OK button's just off the screen there. I'm going to click on OK. That's everything I need in terms of setting up this virtual machine. So I'll click on Review and Create. And I'm happy with that. I'm going to click on Create. Okay, our deployment is underway. I'm going to pause the video because this can take a few minutes and you don't want to sit here looking at the screen refreshing. So I'll be back in a moment. Our deployment is complete. We can click on Go to Resource. Okay, apparently we have a server at this IP address. So we'll copy the IP address, and over in our console, our username was AlertHub, and then the IP. And this is going to connect using my public key. Okay, we've got a server. That's good. The first thing we want to do then is make sure our server's properly patched. So let's do that. That's just going to make sure that any operating system patches are applied. The way we're going to do this is by leveraging Docker Swarm, because we already have the DevOps scripts to start up a Docker Swarm instance for CapHub. In order to do that, we need to get Docker installed on the server. There are a few different ways to install Docker on Ubuntu. There's some standard Ubuntu packages, but the Docker group themselves also make a repository available with more up-to-date software, and that's the approach we're going to take. We publish all of our DevOps scripts on GitHub. In this repository, and you'll see we've got different directories for Docker Swarm, Docker Compose, Kubernetes, Vagrant. So we want to leverage this work that's already been done. In order to do that, we'll need to have the Git version management system installed. I happen to know that Git's already installed in Ubuntu, so we can skip this step. Because we want to pull Docker's packages rather than the default Ubuntu ones, we need the ability to install a certificate so that we can trust Docker Hub, and that's what this command does. We need to get Docker Hub certificate so that we know who to trust, and add that to our key store. We've done that. We're going to add Docker Hub's list of packages to the list of packages we scan, and then we're going to rescan the database of packages now that we've added that new source. You can see there, download.docker.com, which means that this Ubuntu system now knows about the Docker repository, and this command will actually install Docker from that repository. You can tell it's different because it's called Docker CE rather than Docker, which is the name of the default Ubuntu package. So this is going to pull all the dependencies down and make sure that Docker's installed. From now on, whenever this VM restarts, Docker is available to start, but it's not started for us by default. This command will start it this time and make sure it starts in future. So we'll do that. So that means that Docker has started, but by default Docker will only run for the root user. So this command will make sure that our new AlertHub user can run Docker. And that's what we want, because we really want Docker to run in a user space for AlertHub rather than the root space. So we've done everything we need to do as root now. I'm going to log out of the root user. Ubuntu loads group permissions at login time, and I've changed those, so I'm just going to log out, log back in again. If I've done everything right now, I'll be able to type docker service ls, and I get this response back saying the node isn't initialized yet. If I already have a Docker swarm, then I might join this hub to a swarm. If I don't, and I happen not to in this case, then I want to initialize a new swarm with this command, docker swarm init. Sorry, I jumped around a little bit there from the document. So we've created a Docker swarm now of one node, but I can see I've got no services. The step I skipped over, was just to clone that Git repository with our scripts in, so I'm going to do that now as well. Okay, so we can see we've cloned the directory of the project, and we can see all our scripts here, and the ones we want are Docker Swarm. If I go inside this directory, you'll see there are some Compose scripts. This is the only one we care about. These two are going to be removed very soon. And there's a README file. The README contains all the commands you need to get started and some useful helpers for once you're up and running. But we're just going to follow the document for now. If I do my Docker service ls again, I've currently got no services running, and something that Docker Swarm needs is a repository or a registry of different images, and we can run that registry in Docker Swarm itself with this command. This is all pretty standard Docker Swarm setup stuff. So Docker's going out, finding a container image, pulling it down, and then starting it up. And the net result of that if I do my Docker service ls, is that I now have a registry service running on port 5000, which Docker Swarm can use. That's it for all our setup. What we need to do now is to actually get the AlertHub software on this system, and we can do that with this command, this single command actually. And this command is docker stack deploy, so telling Docker stack that Docker Swarm that we want to deploy a full stack of suites. So this command is going to download and install Postgres as a database, Elasticsearch as our inverted indexing system, RabbitMQ as our sort of messaging substrate, the two CAP services themselves, the one that goes out and fetches the feeds, and AlertHub, which is the service which matches alerts to subscriptions and then republishes them. And it's also going to install an Nginx, which will act as a front-end server for those services and just pull everything together for us. The Nginx install is the place where you could do SSL certificates or SSH certificates if you wanted to, but as I said, I'd advise you to use Azure Service Termination instead for that. So we copy the command there. So this is basically setting up all the different parts of the system. I should have shown you the compose file. Actually, while that's just running, I can go into this directory and I can show you the compose file that we're running. You can see it defines some storage, it defines a network, and then it lists the services. So here's our Postgres, here's our Elasticsearch, here's Rabbit. One special image is this setup image. This is a one-time only container which will essentially execute some Elasticsearch scripts that set schemas and search schemas. This is completed, so if I do my Docker service ls now, so you'll be in this display quite a lot. Let me make this screen a little bit wider and then you can see what's going on. Replicas, so the first number here is the actual number of services we've got provisioned, and this is the target. So Docker Swarm is working quite hard at the moment to pull down the images and to start the containers, and over time we'll see this transition to one of one, one of one, one of one. The setup script will be slightly different because this will run and then terminate. And at this stage in the process, so you can see they've already started going to ones. I tend to do a little bit of refreshing. You'll be rerunning this command for a few minutes just while everything gets up and running. If I run htop, you'll see the machine's quite busy. Even on a 4-core machine, it's doing quite a lot of work. On a 2-core machine, it's very busy at this stage. Everything still works okay, but yeah, it is quite busy. What I'm going to do is just pause the video whilst these services reach a sedentary state, and I'll be back in a moment. Okay, we're back. If I run our service now, you'll see we're in a state of 1-for-1s. I don't know how long that took, probably 3 or 4 minutes. Just be patient in this phase. It does take a while, and you'll see servers like Nginx restarting a few times while it's waiting for its dependencies to be fulfilled. We can use Docker service logs as a command. For example, we can look at what the setup script did, and you can see setup was waiting for Elasticsearch to become available, and then once it was available, it wasn't able to find the alerts index, so it knows that it needs to create that index. This is it checking the presence of other indexes and then creating them if they're not there. And we can look at the logs. So for example, we could look at feed facade. And these are pretty useful commands. Feed facade is very quiet except for when it can't do work. And you can see this is well, the machine was trying to start and RabbitMQ wasn't available yet. So it was reporting that. Eventually it has started okay, so there are no more errors. It'd be nice if there was a message saying startup successful there, but there you go. So what do we need to do? We've got a running CAP AlertHub. We need to look at this IP address now. And I'm going to take that and put it in, and then I'm going to go to /cap aggregator. And there's the CAP aggregator. Let me just resize this window a little bit. better. So I'm going to, oh, I can't log in because I've not gone through the setup script yet. So let's go to /setup. That's the first step. I'm going to set up a very temporary user. This will be deleted as soon as I finish this video, so it doesn't really matter. I can leave all these blank. AWS, the Azure install is capable of publishing to an S3 bucket, but you probably don't want to do that, so I'd just leave that blank. Static feeds directory is something we do need to change in this case, and it tells us what we need to change it to there. This is the difference between a development and a production setup, and it's quite important for the Azure setup that you change it to this directory. We'll leave static feed list size default, which I think is 100. Okay, that's everything we need to do to set it up. Not going to save that. So cap aggregator is just initializing itself, and now I should be able to log in using those credentials. Once you've set the system up, that URL is no longer available. Okay, so we've logged in. Currently, cap aggregator doesn't have any subscriptions defined, so this is what the pool of subscriptions we're going to match incoming alerts against and filter them. We need to give it a list, so we're going to load Elliot's default JSON list. That's from this URL. I'll just copy that, and we'll hit sync. So this screen is going off, fetching that URL, which contains about 2,400 subscriptions, 2,410. And you can see it's starting to chew through them and index them. The indexing here is basically spatial and text indexing, so that we can match the shapes of incoming alerts against the shapes of the alerts, of the subscriptions rather, pardon me. I can just pull up that JSON file. It's better formatted. So you can see, and of course you could create your own file which is using this format with your own definitions of subscriptions. So that's how you might do that. What we need to do as well is the same job but for feed facade. So if I copy that URL and I'll go to feed facade setup. The feed facade setup is a little bit simpler, less parameters. I bet you can guess my password. I feel the need to point out that I don't set passwords like that on long-lived systems. It's just for the purposes of the demo. Okay, this is good. So by default, feed facade knows about 120 alert sources. So these are the RSS feeds and other sources that we're going to scan, read new alerts, and then we're going to match those against subscriptions in our database. Nearly there. Just wait a little longer. While this is just completing, I should be able to show a different feature. Obviously, when we're running on AWS, we publish into an S3 bucket, which is the kind of public-facing view. We've not done any work to do something equivalent for Azure yet. So instead, the alerts are written to disk, but then they're shared through the same web server. So I can go to /cap here, and I get this directory of the alerts. And currently, it's populated with a folder for each of my subscriptions. So if I scroll down here, I should be able to find the unfiltered feed, for example. There should be 2,410 directories in here to match the subscriptions. As I start to harvest alerts, folders will appear in here for the sources, and copies of the alerts that I have harvested will start to appear in this directory as well. So this is one possible way to interact with the system. So let's go to subscriptions. So we can see we've got 2,410 subscriptions now. Of course, we're not actively collecting any of these feeds yet. In feed facade, we have a status for feeds. So we've got operating feeds for production ones, and we have testing feeds for testing, and we mark feeds as being not operational if we know that they're broken in some way. Obviously, I don't want to go through 120 and do that by hand. So on the admin menu, we have this enable all operating option. What this will do is to slowly work through the list of feeds and enable 5 at a time every 30 seconds. And the reason it does this is to try and not swamp the machine. If I switched on 120 feeds all at once, there'd be a big spike in CPU usage. So we're just trying to flatten the curve. That's a very topical phrase to use. So if I click on enable all operating, what I can do actually is I can run htop here, and you should see CPU usage start to creep up as we start to enable feeds. Takes a little while just to kick in. Let's do Docker service logs. I was running the right one. I wonder if I didn't choose the right option. Enable all operating. Oh, there we go. It is running. So you can see the green tick means that feeds are enabled and running. And the histogram here has started to fill up, so we know that 10 a.m., so in the 10th hour, it's 10:51 now, we've had one success. We've got no new entries for that. Here we had one successful harvest, which has resulted in 21 new feeds, or 21 new alerts rather. So what's happening in the background is the system's slowly working through the feeds and switching them on. And as I refresh this now, I should start to see more green ticks and red crosses or red exclamation marks. Red exclamation mark if there's an error, and you can see here, this is a certificate validation exception. Here we've got connection timeout, so that's a feeding error. Because we've got 21 new entries, we should be able to see these in Cap Aggregator. Now, as I said, at system startup time, the process can be CPU bound, so we just have to be a little bit careful. So unfiltered feed seems to be working okay. We've got 49 alerts so far, and what we'll find is that as these sources get switched on, this will start to fill up. So you'll end up seeing, oh, there you go, up to 71. So you'll just see this start to fill up with alerts. If I go back to my my disk here, you'll see these are the actual feeds. So if I go into here, I should be able to see actual alerts. Yeah, okay, no style sheet attached to it, but that's an XML document that you can get. So that's our system of record, if you like. That's our long-standing record of alerts. Let's just do another quick refresh in here. Okay, so you can see now that it's really starting to ramp up with the feeds. We've got 4 CPUs all running at 100%. Everything still continues to work okay. It's just very busy at the minute. Eventually, this will settle back down to 20% usage on one core. It's just at the startup. It's kind of hard. So that is Cap Aggregator showing you the different alerts. I should say, this particular view is using the Elasticsearch index of alerts, and this particular view is configured to remove expired alerts. There's a setting you can use if you want to keep alerts forever in Elasticsearch. The alerts are kept forever on disk, but Elasticsearch only maintains an index of those alerts that haven't expired yet. And you can see I put the expiry for the alert just here in the interface. You can flick a switch though if you want to make an Elasticsearch. I've got an Elasticsearch at home that's got about 2 million alerts in it, and it performs really, really well. It's extremely snappy, but it just adds noise to leave them in this, so that's why they're removed. Let's do one more refresh. Again, we can see the load's quite high still, so to be careful. Okay, so those will flow in. The last thing I want to show you then is Elasticsearch itself is also exposed by default configuration, the URL which is /es, and then we use the different collection names. So we're going to use alerts, and Elasticsearch has an _search endpoint. Q is equal to search for storm. I don't know if there are any alerts for. Oh, there are. As it happens, there are alerts for storms. So you can see this is allowing me an API access to the current list of active alerts, and I can use all of Elasticsearch query. So this is using a reasonably simple free text query across the whole record. But if I want to, I could post JSON at this URL, and I could do spatial searches. I could combine spatial searches with scope, public, and status test to just get me the test alerts, or I could say status official if I only wanted official alerts. If I type storm, not in there, storm. Yeah, so that's a prettier view of the data we just got out of Elasticsearch there. Other things I can do, I can create webhooks. So when this subscription receives an alert, I will call this URL with the JSON, the same JSON actually, which is available here. Under the hub, of course, there's RabbitMQ. You can subscribe to the different RabbitMQ topics at the server level if that's a better way of doing integration for you. I quite like the webhooks as a way of working. There's I forget the URL, there's a web-based webhook service you can use to test webhooks, and we've done that with this. It works really well. Whenever a new unfiltered alert comes in, you get a post to a URL with the data. So that is AlertHub running on Azure. Yeah, really happy to field questions or to talk to anybody who has questions. My email address is there. You can find me on Twitter there, and yeah, give us a shout if you have any problems. Cheers.